about all the vocabulary, so we shouldn't have to go back over all that again. If you're confused on any of that, you can go back and look at those notes. So multiplying polynomials, we're going to focus today on multiplying a monomial, so a single term outside the parenthesis, times some sort of polynomial. So it's going to have to always start with distribution. Okay, so we are going to always distribute whatever the monomial is that's outside, okay, into every term in parentheses, every term of the polynomial that's in the parentheses. So for number 1, what is the monomial that we're going to distribute? The 2. What about in number 2? What are we going to distribute? The W. Okay. What about in number 3? What are we going to distribute? Just the 9? The whole thing. This whole term is the monomial. So it's negative 9v to the 4th. That is one term. That's a monomial. Okay, remember we said yesterday monomial can be the product of numbers and variables. Okay, so that's all one monomial, and it's going to all get distributed. Okay, what about number 4? 5x. Good. All right, so you got to be able to identify what am I supposed to be distributing. Okay, then let's actually do the distribution. Let's try it out. So in number 1, I'm going to distribute, this is a trinomial, so it's got to go to 3 terms. So I got to distribute that 2. I've got to multiply that 2 by all 3 of those. So 2 times y squared is 2y squared. 2 times negative y is negative 2y. And 2 times 8 is positive 16. Now, when we look at our steps, it says, okay, after you distribute, combine like terms. So we were practicing combining like terms on the previous notes when we were adding and subtracting. Do you see any like terms here that can be combined? No. Why can't I combine this y squared term and this y term? They both have y. They are not the same degree. They don't have the same exponent. They are not like terms. Okay? They have to have the same variables and degrees on those variables to be considered like terms. Okay? If you need to make a note of what that means, like term has to have the same variables and degrees or exponents on those variables. Okay, so no combining like terms. We've jumped down to the next step. So now it says write your solution, okay, or write your answer in standard form. I think we talked about this yesterday. What is standard form? Okay, it's simplified as it can be, yes, but there's a certain order all of the terms of our polynomial have to be in. Do y'all remember what order we write if there's more than one term? The largest to the smallest exponent or degree. Good. So if you need to make a note of that. So highest to lowest exponent or degree. So in number 1, is this written in standard form? Yeah, we have the y squared, y to the understood first power, and then a constant. A constant is the 0 power, right? Y to the 0 is just the constant. So this is good to go. We don't need to rearrange anything. We're done. All we had to do was distribute, and that was it for number 1. Let's try number 2. When I go to distribute this W to all 3 terms in this trinomial, this is a little different because we're not distributing a number, we're distributing a variable. So you have to remember when you multiply variables, how that affects their exponents. So I'm going to put just a quick little reminder up here on an exponent rule. When you multiply like base terms, so I'm just going to use x as an example. So if I'm doing x times x, whatever the degree or the exponent on those, what do we do with those exponents? We add them. Very good. So I'm going to add the exponents and keep the base the same. Okay, so if I do w times w squared, this w with no exponent written has an understood exponent of what? 1. So this is a 1 exponent and this is a 2, so those added together is a 3. So w times w squared is w cubed. And then w times 2w would be 2w squared. Good. The coefficient stayed the same because there was no coefficient here. And then the w times w is w squared. And then w times 1 is just w. Any like terms to combine? Nada. They all have a different exponent. Is it in standard form? The highest exponent to lowest? It is. We're done. That's your answer for number 2. Pretty straightforward. Now number 3 is a little more complex because when we go to distribute, this monomial is not just a number or not just a variable, it's a product of both. So we have to make sure you remember the rules. When you're multiplying monomials, you multiply the coefficients and you multiply the variables. So the -9 times the -3, what is that? Okay, and is it positive or negative? Positive, because a negative times a negative, we get a positive 27. Now the v to the 4th power times the v squared is going to be what? Are we multiplying the exponents or what did we? Yeah, we just reviewed up here. When we do that, we add the exponents. Okay, so that's going to be v to the 6th. And then now we'll distribute the same monomial to the -7. So -9 times -7. Yeah, it's going to be positive again. It's 63. Now there is no variable on this term, so it's going to just remain v to the 4th. Those are not like terms. I cannot combine them, and they are in standard form. So that's as far as we can take that. All right, I'm going to give you a second. I want you to try number 4. Distribute to all 3 terms in that trinomial. See if it needs to be simplified at all by combining like terms or if it needs to be rearranged to standard form. I'll give you all a minute to try that. You can talk with your group if you have questions, and then we'll check it. Anybody want to share what they got? Think they got it right? It's okay to be wrong. That's how we learn. So when I ask if anybody wants to share, don't be afraid. Yeah, go ahead. Tell me what you got.
Is it 20x to the power of 2 x minus 4x?
Very close. All of your coefficients are exactly right, but let's double check your powers on the variables. So y'all look at the variables here. When we multiply 5x times 4x squared, 5 times 4 is 20, but the x times x squared becomes x cubed. Because remember, when you don't see an exponent on the variable, it's an understood 1. So don't forget that there's an imaginary 1 there. Okay, so then when you distribute the 5x to the -3x, you get -15x squared. And when you distribute it to the -8, you get -40x. Good. All right, let's flip it over. This is a slightly more complex example on the back. Same concept, though. We are distributing our monomials into what's in the parentheses. So what's different in these than on the front? Do you notice? How many sets of parentheses are in one problem? 2. Okay, so on the front, it was just one set of parentheses. So now we've got, oops. So now we've got to distribute 2 different numbers. So we're going to distribute the 2 and the 5. So the 2 gets distributed to the first set of parentheses. So the t and the 4. So that's 2t plus 8. And then the 5 gets distributed to the t plus 7. So that becomes plus 5t plus 35. And then do I distribute it to the 11 as well? No, the 11's not in parentheses. Pay attention to where your parentheses close. Okay, so you don't distribute too far. So that plus 11 is still there, didn't change. Now this time I do have some like terms I can combine. Oh, let me get a different color. I see some linear terms with t. What does that combine to? 7t. And then I see some constants. There's 3 of them there. So I need to do positive 8 plus 35 plus 11. What is that going to give us? Positive 54. So plus 54. Okay, now is that in standard form? Yeah. T, the variable term always goes first and then the constant. And if there were more variable terms, we'd order them by degree. There's only one variable term and one constant here. So that is in standard form. All right, last one, last but not least, same concept. There are 2 monomials with different sets of parentheses that they need to be distributed to. What you need to be real careful of on this one is that you get that negative with the 4x, okay? Because the negative has to be distributed as well. Okay, so in this first set, 2x times 4 is 8x. 2x times negative 9 is negative 18x squared. And then in the second set, we've got negative 12x squared and then negative 44x. All right, and then we're going to look for like terms to combine. I see a couple of quadratic terms with x squareds. And I see a couple linear terms with just x. Okay, so what do my quadratic terms combine to? Good, negative 30x squared. And my linear terms? Negative 36x. Now, if the blue term was first, what I've highlighted in blue, so if you combined those and you wrote this as negative 36x minus 30x squared, that's not wrong, but then you have to rearrange it to put it in standard form. So when I look at this and I'm doing my combining, I just go ahead and look for the highest degree first to save me a step of writing. Okay, so I don't have to then rearrange it. Cool? All right. So what we're doing with the rest of class, you have a practice in Delta Math. So in Delta Math, I'm going to pull it up so you can see what it looks like. I want this to move so I can see. A laptop or a charger? I don't have an extra laptop. I'll get with you in a second. Okay, y'all, your grades on this are just your completion. Okay, I'm not taking any points off for getting anything wrong. So when you're looking at your grades, you're looking at how much of this have I completed? So let me get the student view real fast to show you what it's going to look like. 7th. Okay, here we go. So this is what it should look like when you log in. I'll get the code pulled back up. If you have still not joined the class, you'll click on Add New Class over here if you didn't do so earlier this week. But here's the assignment. When you click on the assignment, you see the categories of problems, and over to the right, the number that I'm asking you to get correct. Remember in Delta Math, it's how many, I'm asking you to get this many correct. It may take you, I only need you to do one of these problems, but if you get it wrong, that doesn't count. You have to keep going till you get one right, okay? Now, when you are doing a problem, okay, so let's say I'm adding and subtracting polynomials. I've got it set to give you 2 attempts. So you can see right here, we're in attempt 1 out of 2. So if I went to go and solve this, and I'm just making this up, this is not right, and I said this was my answer, and I tried to submit it, I'm going to get a pop-up that says this is incorrect. Try to find your mistake. You have 1 attempt left. And I can come back and I can try again. Hopefully you are showing some work on notebook paper. You can use the back of your notes. I think there's a good amount of blank space there. I have notebook paper in the back if you need some, if you don't have your own. Okay, but look back at your work and try to find your mistake. There is a calculator right here, or you can have another window open with Desmos. You may not have your phones out. We are not photo mathing our way through life. You need to be able to actually do this. So have some scratch paper and have either this calculator or the Desmos calculator open in another window, and y'all can talk to each other. You can do show examples and see worked examples. You can see as many of those as you want, and you can watch a video on how to do that type of problem. Okay, and then I'm here too. You can ask me questions. Okay, now if you get it right, or excuse me, if you get it wrong a second time, it's going to look like this, and you're still going to be at 0 out of 2. So you'll have to get a new problem to try again. So even though you've tried one problem, your completion percentage didn't change at all because you haven't gotten it right. Yes. I'll pull it up in just a second. Okay. Now, when you do get one right, that will change to 1 out of 2, and your percentage will update as you go. So as you get some of these done, you'll see your grade change right here. Okay, your due date is August 19th by 11:59 p.m. That is Monday. So you've got today, you've got the weekend, you've got Monday to get this completed. Okay, use your notes, use that example button and that video button, and yeah, y'all get to work. Y'all have the rest of class to work on that. Okay.